In this video, we will compute the triple integral of a function of three variables. So the situation is very similar to that for double integrals. Notice that if you look at the inequalities describing the region, that one of them has constant bounds. In this case, x. The bounds are not functions of the other variables, but just constant numbers. So just like for double integrals, that tells us that this should be the outermost integral, which gets computed last. And then they go in the order that they're written. So if you notice, each variable, the bounds are functions of all the variables that come after. So in this case, the bounds for y are functions of just x, not z. And the bounds for z are functions of both x and y. So again, just like for double integrals, the order is determined by how we write the inequalities. But each integral, its bounds should be functions of the variables that come after. So the bounds for z are functions of x and y, the bounds for y are functions of just x, and the bounds for x are not functions of anything, they're just constants. And in this particular example, the function is just 1, so there's nothing to write here, and the order is z, y, and then x. Okay. But the process is the same as for double integrals, so we just do them one at a time. So first, the integral of dz is z, so just 2 minus x minus y minus 0. And we're thinking of this as a function of y. So I'm not going to do anything special right here. I'm just going to separate the 2 minus x from the y to remind ourselves that y is the only variable and we're thinking of x as a constant. So I'm going to group 2 minus x and think of that as just one constant. So we have 2 minus x times y minus y squared over 2, evaluated from 0 to 2 minus x. If we plug in 0, then everything is just 0, so we just have to plug in 2 minus x. For the first term, since we already have a 2 minus x, we get 2 minus x squared. And here we get 2 minus x squared over 2. And of course we can combine them and get 1/2 2 minus x squared. So let's multiply that out before we compute the integral. That's 4 minus 4x plus x squared. So taking the antiderivative, we get 4x minus 2x squared plus x cubed over 3 from 0 to 1. So we have 4 minus 2 plus 1/3. Oops. Seems I dropped the 1/2 at this step. There should be a 1/2 in front of everything. So we have 1/2 times 2 and 1/3. If we distribute the 1/2, this is 1 plus 1/6, which is 7/6, and that is our final answer.